So to keep with the theme of the last video, here is another example where we could use the quotient rule, or we could solve this using just some algebra, not solve this, but derive this or take the derivative of this using some algebra. So if we were given this function, it does have this form of one function divided by another. We are in luck though, because we have one polynomial divided by another, and even more importantly, the thing on the bottom, our denominator, is a monomial. It is a single term, which means algebraically I am completely in my right to go ahead and split this up, to distribute that division is how I kind of think of it. So I could do this. My pen is not loving me. It doesn't like when I upload things at the same time as make videos. And then I could simplify each of the new terms after that distribution of that denominator. So this is 1 over 5 times x, right? X cubed over x is just, or x squared is just x. We have a 3/5 times an x to the negative 1. I'm going to go ahead and use my negative exponents because I want to be able to leverage that power rule. And then we have a minus 7 over 5 x to the negative 2. I think this is way easier than applying the quotient rule. Next thing we do, we got our power rule come into the rescue. So if this is our f of x, we should be very clear when we're taking the derivative that we're getting our derivative here, our f prime of x. So we end up with a 1/5 by itself. Drop the negative 1 for that power rule. Subtract 1 to get a power of negative 2. We end up with a positive 14 over 5 when we multiply by that negative 2. And x to the negative 3. And then if you want to be cute, sure, you could even go ahead and rewrite this with f prime of x is equal to, we could get rid of all those negative exponents, right? So we could rewrite this in this format if that makes you happy. So let's compare and contrast that to using the quotient rule. All right, so here is our original function, and here is our quotient rule as seen on this page. So we know, right, according to this, our f of x is the numerator, that function in the numerator, and our g of x is the function in the denominator. If we want to move slow, we can go ahead and use that prime notation to write out what we're going to do first. A lot of you have been doing that on quizzes, and it's very lovely. So if I want to find my inverse here, it looks like I'm using my f of x, which is that x cubed plus 3x minus 7. And I'm going to take that derivative times my g of x minus the original f of x. This is our low d high. It's not in the right order for low d high minus high d low, but you can see it. When I do the other examples, I will be sure to use that little, that's a prime. Pretend my face isn't in the way. And this is all over low. That denominator squared. All right. Now you can already see this is a lot of bookkeeping that's coming my way and a lot of algebra to make things cute and make sure I understand how to, like, I don't know. I know a lot of students might make a mistake on that squaring that 5x squared in terms of forgetting to square the 5 also. But let's just go ahead. I'll go ahead and highlight these pieces too so we can see them in the actual formula, as well as in my beautiful work that we're doing for f of x, or f prime of x. So this derivative now, we've got 3x squared plus 3. The only other thing we're taking a derivative of right now is this 5x squared, which will become a 10x. Just a bunch of power rule. And then I'm going to go ahead and square that bottom. 5x squared is just 5x squared is 25x to the 4th. So then we need to distribute stuff, right? Remember what our last answer looked like? Very different than our current answer. So we might want to do some work to get these to look similar to sort of prove this to ourselves. So then we end up with 15x to the 4th plus 15. Oh my God, for a second I thought 15 was wrong. X squared minus x, 10x to the 4th. The subtraction and the 10x are at the same time are going to kill me. But we get 10x to the 4th minus 30x squared plus 70x all over this gross 25x to the fourth. We clean up our like terms here. It looks like we have some stuff to the fourth. We've got some stuff with x squared. And then we could see if this all cleans up nicely. So this will be, I'm running out of room, but 5x to the fourth. I'm going to go ahead and split it up. I think that's easier than combining the stuff on the previous page. We have 15x squared over this, 25x to the fourth, and that's 70x all over the 25x to the fourth. So we can kind of see what's going to happen here. These x to the fourths are a common factor, so they just basically are 1. We end up with a 1/5 out in front. The next one, 15 over 25, is negative 3/5. And we're going to end up with an x squared in that denominator. And then 70 over 25, making my head hurt, but 14 over 5. And it looks like we're going to end up with an x cubed in that denominator. So looking back, we get all of the exact same stuff we got in that first problem. And I think it was more work, in my opinion. So these are the times that we can make a decision. I just want us to kind of have in the back of our mind, just because we have a rule for quotients doesn't mean we should apply the quotient rule. We should see if there's some algebra thing we can do instead. Same thing here. Just because we have a product doesn't mean we should immediately run to the product rule. Sometimes algebra will save the day. And especially when we start thinking about our trig functions, those were the times that we really needed all of our beautiful things that we have. But there's a lot of times that it's going to be more helpful to consider rewriting them because the trig functions have that reciprocal property. If you had something like f of x is equal to x cubed over secant of x, nothing you can do algebraically to make this not have to be use one of these rules, but you could rewrite this as x cubed times cosine of x. Use the fact that we have that reciprocal identity to use the product rule instead of the quotient rule. So just be aware that you can usually manipulate things slightly in your favor if you just slow down and think about the problem before you jump into applying a particular rule.